Hi everyone, thank you very much for listening to my talk. My name is Sara Parvanezadeh Esfahani. I am a PhD candidate in developmental psychology and I work with Jessica Hay. Today I'm going to talk about the specificity of infant statistical learning. Infants' language environment is extremely complex. One way that infants may be able to start finding words is by tracking regularities in their input, an ability that has been called statistical learning. So for example, one statistical cue to find word boundaries is transitional probability between syllables. Transitional probability is the likelihood that one syllable will follow another, and as calculated based on the frequency of occurrence of the sequence xy divided by x alone. We also know from previous research that infants can track TP between syllables in both artificial and natural languages. So we know a lot about children's computational abilities, but we know much less about how they represent the information that they pull out of the speech stream. So in the present study, we look at the specificity of the acoustic representations of newly encountered words. All right, so here's the baby, but here's the word doggy in the continuous speech. Although the infant may not know what the word doggy means or what it refers to, there are different types of acoustic information that he can represent. For example, who says the word? Are they male or female? Is the voice happy or sad? These are examples of indexical information which reflects properties of the speaker's voice. Since this type of information does not differentiate meaning of the words, infants should learn to ignore variation across this category. Another type of acoustic information is segmental features, which are phonetactic rules of language or what combination of sounds make the word. For example, the word doggy and boggy are different in only one onset sound, yet they have different meanings. So segmental features differentiate meaning, and infants should learn to attend to variation across this category. Another type of acoustic cue is suprasegmental information, or the prosody of language. Features such as lexical tone, stress pattern, pitch contour are in this category. Some of these features are more important in some languages than others. Suprasegmental information falls somewhere between indexical and segmental because sometimes it's important to attend to them and their meaning distinguishing. For example, in distinguishing between the noun record and the verb record, but often they're not. So although we know a great deal about infants' ability to perceive these various types of acoustic information, we know very little about how young infants represent these features in words newly segmented from continuous speech. The goal of this research presented in 3 experiments is to address this gap in knowledge. In experiment 1, we looked at the indexical specificity and we asked, do 8-month-old infants represent indexical information in newly encountered statistically segmented words? Previous research suggests that 7.5-month-olds fail to recognize familiarized words in continuous speech when the sex of the speaker changed, but 10.5-month-olds are able to generalize across talking information. Further work suggests that by 11 months, infants are able to recognize statistically defined words when the speaker's voice changed from familiarization to test. So there appears to be a shift in how infants represent indexical information between 7 and 11 months. In order to test the indexical specificity of infants' representation of a statistical words segmented from a natural language, we exposed them to a segmentation language produced by a female speaker, and then we tested them with target words produced by male speaker. Our hypothesis was that if infants can generalize across sex of the speaker, they should recognize familiar words produced by a male voice after being familiarized with a corpus produced by a female voice. All right. As for our methods, participants were 26 monolingual English learning 8 to 9 month olds. In the familiarization, infants listened to 2 minutes and 20 seconds of a speech stream in Italian produced by female native speaker of Italian. We used the materials from Pellucci and colleagues 2009 study. In each familiarization language, 4 bisyllabic words were embedded, 4 bisyllabic words that had phonetically and phonotactically legal syllables in English. So for example, in this language, fuga and mellow were HTP words or high transitional probability words because none of their syllables appeared anywhere else in the corpus. So the internal TP between syllables was 1. Kes and Bici were low transitional probability words because we added multiple instances of the first syllables in the corpus. We had a counterbalanced language, so the HTP and LTP in language 1 were switched in language 2. And this is piece of the language.
Torna a casa con la bici carichi di frutta in bilico sulla sella. La zia Carola si è esibita in una fuga con la bici verde. Se porti il melo sulla bici, forse cali un po' di chili. La bici ha subito un danno dentro la All
right. The testing phase included 12 test trials, 2 HTP words and 2 LTP words that were repeated 3 times, randomized by block. All the test words were produced by a male speaker. We also used head-on preference procedure in both familiarization and test.
Casa, casa.
These are some of the test words.
Bici, bici, bici.
All right, now let's see what we found. In the figure, the green bar is the average looking time to HTP words across all participants, and the salmon bar is corresponds to the LTP words. And the y-axis shows the mean looking time in seconds. The circles are mean looking time for each participant. Our results show that infants listened longer to the HTP words compared to the LTP words. And our findings also replicated previous findings where indexical information was maintained from familiarization to test. In experiment 2, we looked at the segmental specificity and asked, do 8-month-old infants represent segmental information in newly encountered statistically segmented words? We know that infants can discriminate between consonants from early on, and they continue to show language general consonant perception at 6 to 8 months and more language specific consonant perception by 10 to 12 months. Knowing that, our strategy was to expose infants to a segmentation language and then test them with the modified target words that have a change in the consonant of the first syllable. For example, they heard mellow in the language, but they were tested with bellow at test. So our hypothesis was that if infants have a strong representation of segmental information, they should not be able to recognize the modified HTP words at test. We had 24 English learning 8 to 9-month-old infants. The familiarization language had 2 HTP words and also had the syllables of the novel words in the corpus. At test, infants were tested with 2 modified HTP words and 2 novel words. The consonant of the first syllable of both the HTP and the novel words were changed by 1 feature, either by place of articulation or manner of articulation, to have the smallest change. So for example, in language 1, fuga and mellow were HTP words, and the syllables of tema and pane appeared equally, and at test, they were tested with these words.
Sciuga, sciuga, sciuga. Pelo, pelo, pelo. Sema, sema, sema. Tane, tane, tane.
All right. And our results show that infants failed to recognize a statistically segmented words when the consonant of the first syllable was changed by 1 feature from familiarization to test. So there was no difference in looking time between the 2 types of test words. In experiment 3, we looked at the specificity of suprasegmental information and asked, do 8-month-old infants represent stress pattern information in newly encountered statistically segmented words? Although there is evidence showing that infants are sensitive to stress cues, we know less about how they represent this information. There are studies that suggest that stress pattern is integrated into the lexical information, into the lexical representation, but there's also another camp of researchers who suggest that stress information is stored and accessed independent of lexical representation. Given the contrasting evidence in the literature, we wanted to investigate whether infants represent stress information in newly segmented words. To that end, we exposed infants to the segmentation language that included trochaic target words and then tested them with modified target words that had iambic stress pattern. And we hypothesized that if infants treat stressed and unstressed syllables as equally, as functionally equivalent, that shows that they may not have yet formed a strong representation of stress pattern, and they should listen to the modified HTP words longer than novel words. As for our methods, again, we had 24 monolingual English learning 8 to 9 month olds. The familiarization language was very similar to previous experiments. There were 2 high transitional probability words with trochaic stress pattern embedded in the language. In this language, the HTP words were fuga and mellow, and in the counterbalance language, HTP words were pane and tema. In the test phase, in an ideal world, we would have tested infants with HTP words produced with the original stress pattern versus HTP words produced with a violation of stress pattern. In our case, we would have tested infants with trochaic HTP versus iambic HTP words. But we knew that by this age, infants have already developed a trochaic bias. And a preference for trochees in having this design wouldn't allow us to understand that a preference for trochees was because of the trochaic bias or because infants actually represent stress pattern in these words. So we tested infants with 2 modified HTP words and 2 novel words. All the test words had iambic stress pattern, and therefore the stress pattern was violated from familiarization to test.
Fuga, fuga, fuga.
These are the words.
Melo, melo, melo. Pane, pane, pane. Tema, tema, tema.
Our results for experiment 3 show that infants listened longer to the modified iambic HTP words compared to the iambic novel words. So infants recognized familiar words from continuous speech and differentiated them from novel words. Here is a plot, a violin plot showing all 3 experiments, and it shows the distribution of looking time difference between modified HTP words and LTP or novel words. The white dot shows the median, and the vertical gray line shows the middle 50% of the data. And as you can see in the segmental condition that's in the middle, the infants' preferences for test words are equally distributed, and the mean is only 25 milliseconds, so there is no strong preference. Our findings suggest that 8-month-old English learning infants can generalize representations of statistically segmented words across indexical and suprasegmental information. One way to explain the results is that indexical and suprasegmental information in statistically segmented words may be underspecified or weak. Alternatively, it may be the case that indexical and suprasegmental information are represented at some level in these words, but they are overridden by segmental information. In typical statistical segmentation, infants appear to compute TP over syllables, which might make them more attentive to segmental features. So segmental information may either be weighted more heavily as a byproduct of statistical segmentation or because segmental features are more readily relevant to word meaning. Also, the results suggest that infants at 8 months may have already formed a strong representation of statistically segmented words across segmental information. Altogether, our findings suggest that even in a demanding statistical segmentation task, 8-month-olds may attend to the information that is more relevant to word meaning and ignore less relevant cues, such as indexical or speaker variability or lexical stress. At the end, I'd like to thank all of our participants and our lab members, and thank you all for listening.